Hey everybody, welcome to TCP Talks with Jonathan Baker and Justin Broadley from the Cloud Pod. In this series, we're bringing you interviews with the best and brightest leaders and heroes from the tech and cloud industry.
Hey, this is Peter Rasakis, co-host of the Cloud Pod, and I am here today with Rahul Thakkar with AWS, and super excited to get to talk to you today about your new announcements.
Peter, it is such a joy to meet you, and this is the first podcast, the first event that I'm attending since launch, since we were announced this morning. So I can't wait to tell the world about AWS SimSpace Weaver, and it is just such a joy. So yeah, please, let's get started. This is exciting.
First off, I don't understand then how you're still awake. I can't imagine the sleepless nights heading into getting everything wrapped up. That's a huge accomplishment.
Yeah, well, credit goes to the team. We are surrounded by some of the most wonderful people, and it's such a joy, building this product with them and delivering it. But AWS SimSpace Weaver, it really enables our customers to run extremely large-scale spatial simulations without having to manage any of the underlying infrastructure. So it essentially takes your spatial simulation and distributes it across a large number of compute nodes. It even removes the complexity of state management between entities that are or things, people, crowds, cars, drones, as they move about the simulation, and you're exchanging state information among the compute nodes. It takes away that complexity. It truly empowers the customers to run very large worlds using massive 3D objects and millions of real-time interactions.
So prior to the service being released, if I wanted to do this, what technologies were available, and what were my limitations?
So generally, if you wanted to do such a large simulation, so let's take an example of crowds in an entire city, right? You're talking about hundreds of thousands, if not millions, probably millions. And if you wanted to study their behavior, what you would do is you'd take a smaller data set, like 100,000 or probably 100,000, probably a little bit more, and then develop a simulation around it, and then put it inside a smaller spatial environment, run it on a server, study it, and hope that it translates to the big picture. Right. So you would take a sample of your work. And if you wanted to distribute it across many compute nodes, it would take a lot of folks and many years of development effort. And our customers came back to us. As you know, Amazon is first and foremost obsessed over our customers. And they came back to us and said, we have this problem. We want to scale our simulations. And we do see this as undifferentiating for us, because we are doing this over and over again for solving one problem and then moving on to another problem and doing the same thing. Can you help us? And we huddled around that idea, and AWS SimSpace Weaver essentially solves that problem for them.
Right.
So we from taking it from like the 100,000 entities interacting with each other on a single machine, we have moved it across 10 compute nodes, over 1 million entities interacting with each other in real time at 30 hertz. So it's pretty awesome achievement, I must say.
So prior to that, basically a lot of this would have to be done sequentially, and now you can do it in parallel.
Yes.
Across larger areas with more entities.
Yes, absolutely. So, imagine if you divide your world up, and I think the keynote did some awesome justice. Imagine the city of Las Vegas that we are in today, and you wanted to study the behavior of crowds. just AWS, I think reInvent has over 50,000 people present here.
Yeah.
And then there is the rest of Vegas, and then there are people visiting. And you can quickly realize that the problem becomes quite compounded. And then you have, and I think there is a YouTube video which has just gotten released about a simulation done using the 3D data set of Vegas and close to 1 million people walking in the city. What we realized is you run out of room.
Yeah.
There's not enough room for folks to walk. So how would you manage a situation where a large gathering of crowds is in the city? So we divided the problem up into multiple parts, and then we helped our customers author the simulator. They came in with the 3D data, they came in with the crowd simulator, and they developed the simulation as if it was running on a single compute node. Mm-hmm. And then using SimSpace Weaver, both the SDK, which does entity management, as well as the API, which allows you to distribute the problem over 10 compute nodes, they were able to, in a matter of, I think, a few weeks, run the entire city as a single simulation on AWS. So it was quite remarkable. And even us looking at it, right? Looking at the baby that we worked on and worked so hard towards realizing itself, and our customers coming back saying, "Oh my God, this is nuts. This is amazing." And then, we worked with Maxar and got the city of New Orleans in 3D using their 3D data set, and it worked. And we had, I think, the data set from the movie Matrix of New York.
Perfect.
Yeah, New York City.
Perfect.
And we were looking at, we were working with our partners, Duality Robotics. They got the data from Epic. They were the ones who programmed in the crowds. They were the ones who programmed in the vehicles. And then they wanted to do an EMS use case, emergency management service use case, where they wanted to see the behavior of EMS vehicles in a crowded city, reaching a particular point where somebody had a stroke or fell down, and nobody knew what was going on. They were able to use SimSpace Weaver in a matter of, I think, a few weeks again and get it up and about. And they have a simulation running. We have so many use cases like this. We have Lockheed dealing with, and I think it's in the press release as well, we have Lockheed writing a simulator that depicts a disaster situation. And now imagine if instead of people, you're making sure that people receive medicine, food, water as entities from different parts of the United States. And then they get what they need in the time that allows them to be safe, right? The help that they're supposed to receive reaches them on time. How do you simulate that?
Right.
And not only do you have to simulate it once in such a large environment, you have to simulate it over and over and over again. And Lockheed has developed the simulator. And AWS SimSpace Weaver has enabled them to scale the simulation. So, that kind of makes us feel pretty proud. And I think the crowds that were walking around in Vegas that I was talking about, our customer and partner uCrowds were the ones who were developing their crowd simulator, and they released their crowd simulator recently. So, they came back to us and said, "Hey, you guys helped us write our stuff." So it feels really, really good inside to realize how our product is helping our customers. And the fact that we worked from customer backwards is something that allowed us to deliver the kind of value that they're getting right now with AWS SimSpace Weaver.
That's awesome. So how did you get interested in cloud and then the sim space in general?
So it was an interesting journey. I started my career in the motion picture business, so films like Ants and Shrek and others, and I was part of their R&D team. And if you're watching the movie, and there is a big flood in the movie Ants, that's computational fluid dynamics, simplified by a fellow colleague and rendered using a particle renderer that I had developed. And while I was working on that problem, it's a pretty complex thing, and it took us hours to render one frame.
Oh.
And we are if you think about it, it's 80 minutes, 24 frames per second of the film, and you're doing one take of one shot in the entire film, and it's only one layer of just the water falling, right? And so you can imagine the complexity of the world that we were trying to create. And this is back when Shrek was being done and Ants was being done in 1990s. Fast forward, I left the industry and moved into a small startup which was developing technologies for satellite imagery and mapping and such. And we noticed that there is a 3D or a dimensionality to observing things. And we studied large behaviors only to realize that these maps, these worlds are so big, humans can't look at this stuff. It's a lot of information. You can't have 100 human beings staring at a screen just like you see in the movies.
Right.
It has to be automated. After that, I was in aerospace, where simulation is ubiquitous to how we work. But across the board, one of the problems that we did notice is, when you have things that are interacting with each other in a very large simulation, you need to break the problem down. And, throughout this entire journey, having worked in the enterprise with, large cluster of machines while making films, and then later in the mapping side of the world, at some point I realized that you can't keep doing this. It is really expensive to maintain your own It's like something you don't want to do. It's something you don't want to spend your resources on, because you want to take the same people and have them focus on the problem at hand, which is, it could be real-time mapping, or it could be making a beautiful movie, or designing a plane. And that's the problem you want the team to focus on. What if the entire industry pivoted and allowed you to not worry about the compute piece?
Yeah.
And they made it easier and easier and easier. And when I heard about AWS back in, I think, 2009, it was an eye-opener. Like, this was the way to go. So I have been an AWS customer since 2009, 2010 timeframe. And now I'm part of the family. I'm actually very proud.
That's great. So a little bit about the AWS services underlying the technology. So obviously it's a brand new service, but we're all super familiar with lots of the AWS primitives out there, EC2 and EBS, and then a lot of the managed services on top of that with AI and ML services, SageMaker, et cetera. How are you leveraging the AWS primitives below your service?
So as a great example, we use EC2. Mm-hmm. Right, EC2 is one of the services that we use, but we automate the deployment, and then we have for high performance computing, for example, we have the EFA, the Elastic Fabric network, which essentially is an extremely fast network. So it allows us to exchange state information among the instances that are the EC2 instances that are hosting our application. We have, and again, as a managed service, because it's fully managed, all the other technologies that exist around enabling our service to be fully managed. So managing logs, managing the front end, all of the tool sets that are available within AWS, we are consuming them to build the service. So, I think in terms of logging, we have, I forget the name. I think it's CloudFront or CloudWatch.
CloudWatch logs.
Yeah. It, we help our customers get their data and see how things are going in the simulation. We have the ability to write to storage, to S3, so that our customers can take their simulations and essentially write the information out. Because, as I said, these simulations are really, really large, and you can't just observe them from a perspective, because you then only get that perspective.
Right.
And it's impossible for this single human being to look at so many perspectives. In fact, you only get those perspectives. So if you want to look at the entire simulation, then you need to kind of record the state of that simulation and how it moves. So we have S3 and the core services that allows the team to allows our customers to remember what they did, remember how the simulation played out. So all the core services is something we definitely are using, and then some of the higher level services as well.
Cool. So one thing I'm a little bit curious about, and I don't know how much it applies, but I'm curious your thoughts around the whole concept of the metaverse, what Facebook is doing now, Meta, and how maybe your technology would either enable those worlds or not really involved.
Well, so what we love to say is, each one of these organizations have their own vision of a metaverse. Some have an enterprise vision, like Duality Robotics, for example, is building their digital twin simulator. And if you had many digital twins in a world that is spatially oriented, then you can study the behavior of that world. So that's what a metaverse means for them in oversimplified terms.
Yeah.
We build the tools that empower them to build their metaverses. So again, working customer backwards.
Right.
They are our customers and they are our partners. We want them to be successful in building the tools that allow their simulators to become general purpose. Maybe their simulations that they build using their tool sets enable their customers to then solve some very specific problems. So if you want to, let's say, deal with a supply chain problem, and you're working in a large warehouse like one of the fulfillment centers that Amazon has, and you want to track how each package behaves alongside how each piece of equipment behaves, like the robots that we have on the floor, alongside how people move about doing their work. And you want to simulate that behavior. This is a perfect environment. Maybe they want to build a simulation for their customers to realize that vision. And they came back to us and said, hey, we want to do this. Can you help us out? And we're like, AWS SimSpace Weaver. And so that's an example. And I think uCrowds also noted that if you are building a crowd-based simulation for creating a world that they envision for whatever use case they have, then coming back to AWS SimSpace Weaver, they would use us as a tool set to realize what they want to do. So that's the kind of, that's where we envision helping our customers build the world that they want to create.
Awesome. So now I can't help but ask, all the a philosophical question, which would be, you hear the many different theories about the origin of the universe. And then the simulation theory, that we're all living in a simulation. Have you heard this theory?
Yeah.
So if it existed, how many EC2 instances would we need? Probably a lot, I'd imagine.
Well, in that world, you would have AWS.
Yeah.
And in that world, AWS would be in the same form as it is today. And in that world, we would be having this conversation. So it is, I don't know, but it would be the same as it is in this world. And maybe if there is a multiverse, just like you watch in the Marvel movies, and in that multiverse you would have different universes where you would have AWS, and it would be solving a similar problem.
Yeah. Do you think you'll see any similar products coming out of Azure or GCP or any other competitors soon? It seems like you've got sort of the leg up here on this one.
Well, so we look at, we always are customer obsessed. So, you will see, as you may have read our leadership principles, right? Customer obsession is at the top. So we work backwards from our customers. Competition is great. It's important to have that. But we always work ourselves backwards from our customers and innovate on their behalf.
Yeah.
So, I would say AWS SimSpace Weaver as a service, as a fully managed, brand new service today, is the only service out there for managing this kind of infrastructure. But again, it's more focused towards the customer. So we are working backwards from them, solving their problems and innovating on their behalf. That's where I would regard, it's great to have competition, but it's important to focus on the customer.
You focus on the customer and then you let them copy you, basically.
Yeah, we enjoy taking care of our customers, and that's how we grow.
Awesome. That's great. If you were to, obviously the service is brand new.
Yes.
There's, I'm sure, 1,000 things that can be made better about the service or the space in general, no pun intended. But what big problem do you think currently exists in this space that you'd like to solve in the next several years with the service?
So, again, we would love to see, actually, this is a great challenge for our customers to help us envision where they want to go. So, and I can't predict the future, but I can say that we are really excited to see where our customers take the current incarnation of SimSpace Weaver, and then come back to us and say, AWS, we would like some more, and here are the things that we realized are still undifferentiated for us, and we will look to you to help us realize them.
Right.
And that's when we will get that, we will get that feedback through iterating over what we have today. And I can't comment on the future, but I can definitely say that that's the journey that we are going to take.
Great. That's great. Well, it's been great to talk with you. Are there any other highlights of the product?
Well, it's like being a kid in a candy store. As the leader of Simulation Technologies organization, when you launch a service, it just gives you like this warm and fuzzy, right? It gives you great joy. It's a lot of fun work, and this is why I'm in the business. But this whole concept of working backwards from the customer, you hear about it outside. When you hear as a customer the keynotes and such, and folks talk about it, and then you're part of that endeavor, it really makes us realize how good a product we're building. But as you can see, AWS SimSpace Weaver is a managed service. It's a fully managed service. It allows you to essentially remove the burden of managing infrastructure when you're building a spatial simulation. It allows you to remove the burden of distributing the state of all the entities that you're managing in your simulation. So what you're focusing on is the behavior of the simulation itself. And from a customer's point of view, this is an extremely powerful statement because we are making it on their behalf.
Yeah.
Right? And I can't wait, and I kid you not, I cannot wait to see how our customers are taking this service to the next level for solving their problems.
Right. Yeah, and that's interesting because it's obviously a pretty new service just in general in the market. I would imagine it's going to open up opportunities for companies to do things that they wouldn't consider doing prior. What percent, if you had to guess, what percent of workloads do you think you're going to get that are maybe customers were already doing simulations, but this is just going to make it better, faster, easier, and they're going to migrate to this service versus these are all net new initiatives because it wasn't even possible before?
So we have heard both sides of the story. So, companies have been doing simulation for ages. Some of them are spatial in nature. So they would definitely want to take their simulators that they've written and scale them. It's hard to tell what percentage because this is a net new service.
Right.
But again, we'll be tracking this quite with a level of curiosity, and then there are folks who would be like, okay, I really wanted to do this. I never had the opportunity to. I'm a developer. I want to give it a shot. And then something amazing comes out of it. And that might create an entire industry. I don't know. It's both the innovative portion and the enabler portion, right? Which we have delivered on behalf of our customers. And I can imagine being a customer, hearing about this service, and talking with my developers in my company, saying, "Hey guys, we've been building this for a while. Can we use this and shorten time to market?" And then the team would be unleashed on solving the problem. So both net new and I think migration is something that I see happening.
Yeah, and the migration is probably, the ROI calculation is probably pretty simple because they have their existing workload. They know what it's going to cost on AWS to run it. There might be a cost savings. There might be time to market savings.
Oh yes, the things that we talk about, right? Elasticity, cost savings, agility, innovation. Like these are some of the reasons why people come to AWS in the first place, and it touches on all. AWS SimSpace Weaver touches on all of those points.
Yeah, and then you have the net new workloads where the ROI calculation is not so easy.
Well, so the interesting part there is can we do this ourselves? No, because why would we, right? It's already there. It's like, would you ever write an operating system today? And you would probably download Linux, or you would, if you're working on an IoT platform, you would use AWS Greengrass, or, if you are on a Windows-based machine, you would never write the operating system.
Right.
You would, or a Mac, but you would use what's there. If you wanted to edit documents, you would never write a word processor.
Yeah.
If you wanted to build a spatial simulation, and you wanted to make sure that the entities scale and communicate with each other in real time, you have to. That's one less problem you have to think about.
Oh yeah.
So, and it's a very big problem. So I see them coming, and in fact, I've been having conversations with old friends who I worked with, and they're like, "Dude, this is totally what I wanted."
That's great.
You're so lucky you get to work on this problem. And I'm like, yes.
And what industries are most excited about? Obviously, you mentioned aerospace.
So think about smart cities, right? So organizations, both local, state, federal, across the world, that are trying to solve problems like, hey, I'm in the city of so and so, or I'm in a small country, let's say, and we are about to change the transportation patterns because of us building this big bridge or this big thing, big mall or something, and this will change the pattern and behavior of the entire city.
Right.
Or I'm a port, and we have shipping coming in, and we want to simulate how our containers are moving in and out. In case of a pandemic, in case of a geopolitical situation, how do we do that? Well, work with our partners, let them write the simulators for you, and they would be using AWS SimSpace Weaver as if they are using the cloud.
Yeah.
It's part of their development pipeline now. So that's one of the industries. And of course, logistics and supply chain. When you're talking about large-scale event planning, so if you're doing sports and such, so wherever you need to simulate a large problem where you have digital replicas of the real world, and there are many of those, and you want to observe the interactions, that's where I would say AWS SimSpace Weaver would be the right tool to apply. And then, of course, there are places which we haven't even thought about, which I'm sure our customers will come back and say, we used AWS SimSpace Weaver to do something, and it would be like, whoa, we had no idea you could do that.
You think they'll have any applications to competitive sports?
I don't know. Maybe. I mean, we'll help them out if they come back.
Well, as a Niner fan, I would say just make sure it's not for Seattle.
I'm when it comes to sports, I'm a fan of cricket.
Oh, nice.
Because I grew up in that side of the world, and I'm very passionate about the game. So any such large venue is welcome to be simulated on AWS, because ultimately what we are doing is striving for making sure that the world is safer and better. So and that experience that we get in those events is something that we remember for a lifetime.
Well, that's exciting. And yeah, I'm really looking forward to seeing the customer use cases start to pour in on this, because it is super interesting, brand new space, at least for me.
Yes, for all of us, it's something totally new, and I'm inviting the developer world because this is the part where you get to have fun.
Yeah. Awesome. Well, thank you for your time, and best of luck moving forward. I'll be watching closely.
Thank you very much, Peter. Such a joy.
Visit thecloudpod.net to subscribe to the show, join our Slack channel, or sign up for our weekly newsletter. You can also find information on reaching our audience through a CloudPod sponsorship opportunity. A big thank you to today's guest, and thank you for listening.